Alright, today we're going to talk about the angle addition postulate. Before we do, I want to remind you of the other postulate we know, which is, anyone remember? The segment addition postulate.
Oh, I do.
So the segment addition postulate segment addition postulate said that point B is on the segment AC if and only if, you guys remember that I use IFF for that, if and only if AB plus BC equals AC. So
oh, I do
the
remember
diagram to represent that was like this. Here's our point B. We know that it's on this line segment if this plus this length. And then we can apply that to do some math with these different segments and figure out different things as we practiced on the homework. It's sort of common sense, but the way that it's stated might not be common. We know point B is on this line segment if and only if this plus this equals this. Alright, so the angle addition postulate is going to be formulated or stated in a similar way. Okay, if we have an angle that is formed by AVC, right? This is angle AVC. I'm using V just because that's the vertex in this case. That's going to be pretty common. The angle addition postulate says that point B we'll put it right there, is interior to angle ABC if and only if, and this terminology is going to be a little new, the measure of angle ADB plus the measure of angle BVC equals the measure of angle AVC. Okay, so if this is point B, we know that it's interior to this angle if the measurement of this plus the measurement of this equals the measurement of the whole angle. This is kind of how we state the angle addition postulate. Basically what it says is this plus this equals this, right? But I just love the way they formulate these things because what this is really showing us is what does it mean for a point to be interior to an angle? What does it mean for point B to be inside this angle? What it means is that it forms two new angles that add together to equal that total angle you started with. Which is kind of a cool application of this angle addition postulate. We could almost think of this, instead of the angle addition postulate, as like the definition of an interior point. In a way, that's really what this is getting at. what is it for this point to be interior in this angle? So, can I erase this?
C.
So this little script M, like the cursive M, that means the measure of an angle. You'll see that a lot on numbers. If I have something like this, A, B, oops, B, C, let's say I know the measure of angle A, B, oops, I'm not doing very well with this. Measure of angle AVB equals 35 degrees. The measure of angle AVC equals 100 degrees. What is the measure of angle BVC?
135.
Look closely at what it tells you. What I would recommend you do with these problems is actually label.
Oh.
Actually
That's,
label everything.
65 degrees.
So the measure of angle AVB is 35. So I would start by going like this. Here's AVB. That's 35 degrees. Right? AVC, that's this whole thing. Right? So the measure of this is 100 degrees. And then I'm looking for just the measure of this here, which must be added to 35 to equal 100. So 100 minus 35 would be 65 degrees. So this one would be 65. Labeling your angles is going to be a very good practice. All right. Give me another minute with that. Good? All right. Let's do one more. Actually, I'm going to do one more. So let's say we have something like this. So there's our little diagram. Here are our givens. In geometry, often you hear that word. This is what's given. The measure of angle GFN equals 4x plus 10. The measure of angle NFE equals 14x plus 3. The measure of angle GFE equals 157 degrees. And then what they want us to find, so given this, find the measure of angle NF.
Hold up.
Right, all of them.
Definitely wrong with
I like the other one
You would
better.
just solve for x and then plug x into the measure of angle and
I thought we were moving into geometry to get away from algebra.
Geometry is basically algebra
You
1.5.
add 4x plus
I can't
10
escape.
plus
Okay, wait, wait.
14x plus 3 equals 157.
Okay, let's number these. So let's say GFN is 1 NFE is 2 and GFE is 3. So GFN, that's this angle, right? Right here, that's 1. GFN. NFE, that's this angle over here. We'll call that 2. And then GFE is the whole thing. We'll call that 3. So we know that 1 plus 2 has to equal 3, right? You guys see that?
Yeah.
So 1 is 4x plus 10.
Wait.
2 is 14x plus 3. Has to equal 3, which is 157. Can combine like terms.
What is 144 divided by 18?
7 degrees. Subtract 13. So we have 18x equaling 144. And then, just as you said, divide by 18. How many times does 18 go into 144? Well, it goes into 180. It goes into 180 10 times, and this is 36 less than 180, which is
So
2
8.
times 18, so it's 8, right? X equals 8.
Then that's
So x is 8. How do we find angle NFE? We just plug it in.
That's 112 plus 3 is 115.
Right, so 14 times 8 plus 3. You said 112. So that would be 150 degrees.
Can we use that?
What?
Can't we just like carry a find it on every roll with us instead of doing
So
this?
that's a really good question. Couldn't we just measure this angle? And no, the answer is just no, because diagrams do not actually have to be drawn to scale in geometry. You could draw this however you wanted, right? I could draw it like this.
And then you can check your answer by plugging in
Uh-huh.
8 to the rest of them and adding.
This clearly is not 157 degrees, right? But if I draw it like this and then I say these are your givens, then we just assume that that's true. Even though I know that if I actually measured that with a protractor, there's no way it would be 157 degrees. So protractors aren't actually used that much in geometry. It's more when you're doing constructions and you have to draw the angles yourself that you would use a protractor. A lot of geometry is just going to be using these theorems and postulates to prove what the measurement of an angle actually is without measuring it. Alright, can I erase this?
You can actually get protractor apps on your phone.
Oh yeah.
Yeah.
How?
Does it take a picture of it?
Camera overlay, like you can just hold it and it like overlays the protractor and it has measurements.
Oh, like